So when we're looking at this square, we can see that it's shaded. The top third is shaded. If we look at the square from the top down, we can see that 1 out of 3 rows is shaded. So we can say overall that this is a third shaded. But equivalently, we could look at the square and say, well, there are 3 shaded squares out of 9. So you could write this also as 3 out of 9. And it would be the same. These are equivalent fractions. Notice that the second fraction here could be cancelled down. You can say that if you divide both the top and the bottom by 3, you get yourself 1/3. And that's how you then cancel the fraction down. Let's have a look at this example of these examples then. So completing each of the following expressions, if it's 3 out of 4, what would it be out of 12? So we just look at what we've done here, and it's just timesing it by 3. To make it equivalent, we just need to times the top by 3 as well. So this would be 9 out of 12. For B, if we have a look at this and think, right, well, what's happened to the bottom there? That's just times by 5. So we'll just do the same to the top. 2 times 5 would be 10. And that would be equivalent. The third one, same sort of thing. You know, what's happened with the 6 to get to the 18 is just times by 3. So we can do the same with the top. If we times the 5 by 3, we get 15. And therefore these fractions will be equivalent. You've guessed it for the second one, for the fourth one, sorry. We'll just look at what's happened to the denominator. The denominator is the bottom part of the fraction. And then just do the same thing to the numerator. So the denominator here is divided by 4. So we could just divide the top by 4 as well to get 1. And then these would be equivalent fractions. Okay. So in this final set of examples, how can we simplify these? Well, if we write 8 over 18, that could be written also as, let's say, 4 times 2, and the 18 is just 9 times 2. In the same way that we could simplify the top fractions from the earlier examples, we can simplify this by cancelling out the 2's. You can only cancel out in fractions when you're multiplying. If I said here that this was 4 plus 2 and that was 9 plus 2, I couldn't cancel the 2's out. But because they're multiplied, I can. So I can cancel these. And that leaves me now with the fraction 4/9. I could continue with this. I could say that 4 is equal to 2 times 2, and 9 is equal to 3 times 3, but because I don't have the same number on the top and the bottom, I can no longer cancel them, so this is the simplest it could be. For the second example, the 5 is a prime number, so I can't actually break that down into anything else. Now I could break down the 40 into 20 times 2, or I'm going to break it down into 8 times 5. The reason for that is because I can cancel the 5's. If I cancelled that, I wouldn't be left with nothing on the top, because really this is the same as saying 5 times 1. It means that if I cancel the 5's out, I'm left then with 1/8, and that can't be simplified any further. In the final example, I've got 12 and 32. I can break this down in the 12 into 6 times 2. I'm going to do that. 6 times 2. And the denominator, the bottom part of the fraction, I'm going to say that that's 16 times 2. Now the 2's can cancel here. That leaves me with 6 over 16. That wouldn't be left in the simplest form, because look, I can still cancel this. I can still write the 6 as a 3 times 2, and I could write the 16 as an 8 times 2. So I'm going to just continue with this. I'm just going to say that's 3 times 2 and 8 times 2. And I can still cancel those 2's, leaving me overall with 3/8, and that can no longer simplify. That's as far as it can go, because 3 is prime and it doesn't belong in the 8 times table, so that is as simple as that can be.